Ladies and gentlemen, thank you for coming. We're going to start. My name is Glenn. I'm a program manager on the WCF team. I'm really excited to be here. And I know everybody always says that, but I have a story. Good friend of mine, Shai Cohen, you guys might know him. He's come here and presented here several times. And he always talked very, very highly about this event. Of course, I was always jealous because he was going consecutively several years and I never went. And
I'm really excited about Windows.
I guess I was chatting with Yan about 8 months ago or 9 months ago, and he's like, "Hey, do you think you're going to come to Belgium TechDays?" I'm like, "Oh yeah, that's that awesome event." And well, I'm not on the list. Nobody's going to, I'm not going to be there. And he's like, "Well, you should see what you could do." So then, through the magic of Twitter and IM and everything else, I found out who the person was who was helping to organize the event, Katrine, and then we started chatting, and I got on with her, and I get really energetic. I got really excited over IM. I'm like, "Katrine!" She's like, "Yes." I was like, "How are you doing?" She's like, "I'm doing great." I said, "I've heard all this great stuff about TechDays Belgium, and I would love to come, and, my friend Shai told me all about it, and this, that, and the other." And she's like, "You're on our list of people that we wanted to talk to." Awesome! So here I am, very excited. Thank you for having me here. You guys have a beautiful country. Wow, I actually got some feedback. This is promising. Does it mean when the room's not full? Because if any of you guys know me, and if you don't know me, you'll learn now, I really like having interactive sessions. I really like hearing what you guys think and giving you guys answers to whatever questions you have. And you can throw bile too if that's what you have to do. I mean, I just want to engage and talk to you guys. The reason I come across is not just to stand up here and show you stuff. It's I want to learn what you guys are doing, because the more understanding we have of what you guys are doing, the better software we can deliver, the better platform solutions we can deliver that actually ends up making your life better. This is all ad hoc, by the way. Inspirational moment. All right, let's move on. So we're going to do two things in this talk. We're going to talk a little bit about REST. We're not going to spend a huge amount of time on it, but just to get on the same page, what REST is, what REST isn't. It's another interesting story is I joined the WCF team about a year ago. Prior to that, I was dealing meth. Didn't have to go to jail for that, though. And when I went to the WCF team, my understanding of what REST was, it's not SOAP. It's not SOAP. It's nice over the web. I can send it to a browser. And that was the limit of my understanding of REST. Little did I know. And then through a bunch of folks from the community, people like Sebastian Lamla and Mike Amundsen and others pointed me in the direction of looking at the HTTP spec and looking at Roy Fielding's dissertation and doing a lot of kind of went off on a year-long, I don't know what you'll call it, journey to learn about what REST was and what were the benefits. And the more I got into it, the more I really understood that there actually are some great benefits. And the other thing I understood was that 99% of the people that use the word REST don't mean it as the way it was intended by the person who coined the term. They mean it in the way that I thought about it. You might say, well, so what? Well, the so what is that there's a lot of benefit when you build systems in a RESTful way. So let's define a couple of things. First, if you have to give a one-line definition of what is REST, REST is a set of constraints over HTTP. It's a way to use HTTP. It's not limited to HTTP, but the first incarnation of REST was HTTP. Roy Fielding, who worked on the HTTP spec, wrote a dissertation. And when he wrote that dissertation, what he was trying to do was say, if we look at the characteristics of the web, what is it about the architecture of the web that makes it as scalable as it is? It's like the largest scalable application that exists. And so he wrote up this dissertation, and he said, I'm going to call these principles REST. An architectural style is actually the literal way it's defined. So if you want the shortest definition, REST is an architectural style. What does that mean? I say when you think about what REST is, when I said it's a set of constraints, it means it's a set of rules that if you follow those rules, you get a whole bunch of benefits. Now, that doesn't mean you have to follow those rules. Some people get really opinionated and dogmatic. What I think is important is being intentional and understanding that there are trade-offs. If I build things in a RESTful way, I get a whole bunch of benefits, and maybe you could say I do sacrifice some things. Maybe it's not as toolable. Now, there's a lot of back and forth and pros and cons on either side, but what I'll say is that the real benefits that I've seen over the year that I've been learning about REST is, one, evolvability. Today, when we build systems that are SOAP-based services, the clients get a static view of a service at a point in time. What happens if that service changes its definition? What happens to those clients? Anybody? It what? It breaks, right? It breaks. So that means that every time I try to evolve my service, my clients are going to break. Now, WSDL is there so that my client can refresh when it breaks and get the latest definition. But it still means they're having to rebuild their systems. They're having to recompile. There's no way those systems are going to evolve without that recompilation. So that really ties me, because I can't bring my systems forward without impacting those clients. Now, if the web was built that way, it would not exist. There's no way the web could survive. We have all different types of emerging standards and things. HTTP evolves. We have HTTP 1, HTTP 1.1. Yet those servers of the web continue to function. Why? Because when Roy wrote his dissertation about REST, he was talking about how those servers were designed. Those servers were designed so they could get these evolvability benefits. Wouldn't it be nice if I could add new capabilities to my services, allow new clients that come on board to be able to take advantage of that, but the old clients just continue to go along their merry way? Those are the kind of promises that REST brings, and it's not religion and dogma. It's how the web infrastructure survives today. So that's one thing. The second thing you get is scale. Scalability. Why? Because what the web is designed for, the web is designed for intermediaries. It's designed, and what is an intermediary? An intermediary means that when I go to a server and I say, get me something, get me some resource, that URL, it's a myth to think that that URL is a location. It's not. That URL identifies a resource. And intermediaries along the way, as I'm traveling across the web to my destination, will opt in if I've played by the rules and say, you know what, I'll give that to you. You don't have to go all the way across the universe of the web to your origin server because I have that representation. This happens when I use an HTTP GET. If I use an HTTP GET, servers are ready, willing, and able to opt in and help me. Even if I do a put, same thing. And then I can even go further and give those servers additional information in the form of the control headers. I can give them caching information. I can give them e-tags and say, hey, I have this identifier. Can you validate whether that e-tag, whether the representation that I got back that's associated with this ID, think of it as almost like a primary key that is a version stamp. It's a key that says, this particular representation at this point in time, here's an ID. And I can go to a server and say, is this ID still valid? And that request is minuscule compared to the full request. And the server can say, yes, that's still valid. That this handshaking goes on. And then my client says, great, I'll just use the cache. Your browser does this. So the real question is, if HTTP is in the infrastructure of the web and it works so well, why do we have to worry about it? Like, it just works. I don't have to think about it. But I just gave that example of the SOAP services, where those services, when they evolve, when the service evolves, the clients break. So one of the reasons you care about it is because you want to get that evolvability with your own services. The other reason you care about it is because you want to get those caching benefits. And the reason why you have to worry about this stuff that used to magically just get taken care of for you is as soon as the communication is no longer happening just with your browser, now you have to start to worry about it. I'm serving you up some information, I'm a server, and you're going to consume it, and it's a very deliberate type of interaction that we're having. I have to be cognizant of giving you the right pieces of information and playing by the right rules. The servers have to play by the right rules as well so that you can get that caching experience that you want. And I, as a client, need to give the right information that will allow those intermediaries to do their job. So evolvability, scale. Simplicity is a third one. WSDL is not simple. I mean, just open, how many people here have written WSDL by hand? Please, nobody. I feel really bad for you. You need the tooling experience with WSDL because it's this proprietary protocol that the average human being doesn't understand, or if they, like I said, I feel sorry for you if you do understand it. If you don't understand it, you don't want to understand it. But HTTP itself is not actually that complex. It's a body, it's headers. The headers are very clear. The content is very clear. The semantics of HTTP are very well defined. If I want something to be cacheable, do a GET. If I'm doing something that's going to cause a change on the server, do a put or a post. Obey these rules, but it's very, very simple. So I think that's really this tension that goes on. And yesterday, after I gave my talk, the first thing somebody came to me and said, are you guys doing the WSDL thing? And I was like, no, we're not. Because we want to offer people the ability to build those systems that can get that evolvability. And we're going to dig into that. So let's dig a bit more into all this stuff that I'm talking about, but that's just giving you kind of a high level of what REST is about. And there's other things that it's about too, but I would say if you just took away that it's about evolvability and scale and simplicity, even though those sound like very high level words, you're on the right track. It's not about pretty URIs. It's not about responsive experiences in the UI either. Even though a lot of the people that use the term REST, the 95 or 99% case, are just saying, look, I got my browser, I want to use some jQuery so that it comes back in a more responsive way, I want to use this AJAX thing. That's not really, that's like really minimizing the benefits that HTTP can bring to you. That's looking at HTTP as just a way to get something across the wire from A to B. So, REST by definition is clear. REST in practice is highly overloaded. But one of the things that's interesting is there's a guy named Leonard Richardson, and there's this book called RESTful Web Services. And what Richardson tried to do is, there was all these debates about, is it high rest, low rest, medium rest, whatever it is. And Richardson was like, look, that's the wrong angle. REST is very clear. Then there's HTTP. You can use HTTP in a lot of ways. Using HTTP to do AJAX type things is fine as long as you recognize that you're not getting those other benefits, that there's more coupling on the client, etc. So it's not to say that the HTTP police or the REST police are going to come after you if you don't necessarily do everything exactly right. But one of the things that Richardson did, and I want to take you guys through this quickly, and yeah, we're going to get to plenty of code, so don't worry. Is this concept that he came up with, this model he calls the HTTP maturity model. And what he did was he looked at the ways you can use HTTP. And as you go up this pyramid, you get closer and closer towards REST. And at the top, you are building things in a RESTful way. And he just used it as a mechanism or a tool to clarify the differences and the trade-offs. So I thought we'd go quickly through that. Ooh. Can you guys actually read that? Probably not. Okay, I'll just describe what's there. Yeah, great for themes. The first level, single URI, single verb, is really what POX and SOAP are. It's this idea that I have a single URI, and it doesn't obey the semantics of HTTP. It's probably over a single method. Like SOAP, for example, is over a single method. It's over POST. That means all those caching benefits just went out the door as soon as I make my first SOAP call. Because SOAP implies the idea that it's a remote procedure call. I am making an invocation. I expect that when I make that call immediately or sometime thereafter, some code is going to execute as if it was running locally on my machine. So what this is showing here is that it has create, update, submit, delete, cancel, approve, find is what you can see in that text. Let me see if I can highlight that. Actually, this might not be so bad. Let me see if I could just... I'm not going to do this for everything. Let's just do this. Here, here. There we go. Cool. So this is showing all these operations that are being tunneled to a single URI. The downsides to this are many. You don't get any of the caching benefits. The servers can't help you because it's all being tunneled. You don't get a lot of those evolvability benefits because everything is tightly coupled. I have to know exactly how to send those messages in order to be able to access the different capabilities. If new capabilities get added, I'm screwed. My client has to be revved to be able to take advantage of that. The next level up is a common one, and this is where a lot of the APIs that you see out there tend to fall that call themselves RESTful, like some of the Flickr APIs and things like that, is where you basically are exposing the different operations of your system as resources. They're URIs. They're separate URIs. But you're still not obeying the semantics of HTTP. The semantics of HTTP with regards to HTTP methods are very clear. And it's basically about idempotency and being safe. Idempotency means that if I call a particular, invoke a particular resource over and over again with a certain method, then it's not going to have any side effects. It's not going to cause any change. And safe means that, well, so idempotency means if I call it once or I call it 50 times, it's the same. Idempotency means that, safe means that it's not actually causing any change in the system. So if we look at the core HTTP methods, which are put, post, get, delete, get is idempotent and safe. This is why a million servers can poll my server at the same time, and that's okay, because of the fact that get should not cause any kind of change on the server. It's safe to call it once or 50 times. A lot of people, when they start to look at moving their systems, their transactional systems, to expose them over HTTP, a common pattern is to say, I'll just poll. I went to go send some information. I'm not sure if it got received correctly. I can just continually poll. Now, polling may sound like a bad thing. It is if no intermediaries existed. But because these intermediaries exist in the middle, they can just stop short and say, that thing is still the same. You don't have to go any further. So that's get. There's post, which is not idempotent or safe. So post means if I post 5 times to a resource, that's caused 5 changes. There's put. Put is not safe, but it's idempotent. So put means if I put the same value 5 times, at least from the client perspective, the server there still could be some side effects, but they're not side effects that I'm responsible for worrying about. I don't have to feel like I might have corrupted data. For example, someone might be tracking the number of requests. Even if I do a get, somebody might be tracking that. That's some state that's changing, but I don't know about it. I'm not deliberately doing anything related to that. And then there's delete. Delete is also idempotent and safe. If I delete once or delete 5 times, it's the same effect, but it's not safe because it does cause a change on the system. So that's what these methods are about. So in this model here, you're getting the benefit of a bit more discoverability in the sense that these things are exposed over URIs, but you're not getting a lot of the caching benefits. The next level is multi-URI, multi-verb. So if you look, well, let me quickly do this one as well. Okay. Where is it? Okay. So what this model talks about, level 2, is I'm actually now using the HTTP methods correctly. I'm obeying the semantics. So if you look here now, the difference between the two slides is in the first one, I literally was exposing those operations as resources. Create, update, delete, etc. Here, I'm actually using HTTP methods. So you can see that to create an order, I'm doing a put, in this case, on my orders resource. That's to up, yeah, okay. So I'm using my HTTP methods. If I want to retrieve an order, I'm going to go to orders/1234, do a get. If I want to update that order, I'm going to go to the same URI, but I'm going to use a put. So I'm using the web the way it's supposed to be used. The one challenge, though, is around the evolvability. So if you imagine this order system here, I still have to know how to create URIs. My client still has, even though it's using the methods, it has to know that to create an order, I'm going to create this URI and go here, and then to approve that order, I'm going to go to this URI over here. So I still got this coupling. So the last level, and we're going to see a demonstration of this in code, is what's known as hypermedia, which sounds like a scary term. Okay, I'm going to do this again, because this one is too good to miss. So the challenge we were just talking about is that my clients are still coupled to know how to build up URIs. Is there some way to break that? It turns out there actually is. And it's a way that you're actually familiar with, you're just not probably cognizant of it. When I go to, say, Bing or Yahoo.com or Google, and let's add my own profile, and the server wants to give me some type of information that it thinks is interesting for me, it serves me up a hyperlink. And maybe it has some type of image that says, you know, this is new, or you know, get it while supplies last, whatever it is. As a human being, I'm able to see that, and I don't get that breaking experience. Those portals are changing all the time, but I continue to function. I can still find the things that I want to do. So the question becomes, what happens when machines are talking to each other? Can we give them that same kind of experience? We can't really draw the image, but we wouldn't want to. But we can give machines metadata. Metadata that says, here's something interesting that you might want to know about. And once we do that, we decouple that system from knowing about how to build up URIs. So let me make this even more clear. I've got my order processing system. If you look at the example that was there, I have multiple URIs. And usually that would translate, if it was a SOAP model, to multiple services. I would have my order creation service and my order approval service. I'd have all these WSDLs that I'd be coupled to, and if one of them broke, I'm hosed. So, and I have to know where to get them, where to go to get that WSDL, et cetera. The link model says, don't worry about URIs. Instead, you look for that picture, and the picture, in this case, is what you're seeing here that says rel. So when I create my order now, instead of just getting back an order, I'm going to get back links within that order. And those links are not static, and this is the big difference between WSDL. With WSDL, it's like I've got a type library. There may be conditional code on the server that when I invoke that method, it might throw an exception. But my client has to know how to deal with that. In this world, the server is offering up at every point in time the allowable things, the things that make sense for you to do. You're modeling a business process. You're modeling a state machine. In this case, the business process is submitting orders. And the server at each stage of the game is saying to you, based on the state that you're at, here's the things that you can do. But the real advantage of it now is I don't have to know about the URIs. All I have to know is I look for a link, I know about that rel. That's all I know about. And once I get that rel back, the URI has already been formatted for me by the server. The server has already predetermined where I need to go because it knows who I am, it knows the context of what I'm doing. It's able to do that. Just to drive that home, here's an example of a hypermedia-based response. Now, the web and HTTP is about media types. Text HTML is a media type. Text XML is a media type. SVG is a media type. All these media types are part of the evolvability of the web, that resources can have multiple representations. And the coupling, whereas in the SOAP world was around WSDL, there is coupling in the HTTP world. It's around the media type. Let me tell you guys a great media type that has plenty of coupling in it, but it offers tremendous capability. Atom. When you work with Atom, you know there's a schema. But the schema is not about the service itself. The schema is about the payload of what's going back and forth. And the semantics of edit and working with feeds are all embedded in. And I know that because I get back a media type that's not just XML or JSON, it's Atom. It's Atom plus XML. And I can go find an RFC that explains to me that, hey, when you're working with Atom, you're working with these feeds, and these are all the semantics. We'll take that same model now and say, instead of my order coming back as just application/XML, it comes back as something like this, Contoso orders plus XML. That now means I don't just have an XML, I'm taking part in a business process. I'm working with Contoso's system. Contoso's system can have documentation that defines for me what these rel tags are that I need to care about. And then, at any stage of the game, my clients are more adaptive. My clients know to look for certain things, but the beauty of it is, if my order is not in a state where it can be approved, I don't see an approved link. So there's no conditional code that suddenly breaks if there's a change on the process on the server that suddenly says, well, now when we approve, we have to have this additional step. I'm not going to call it and get that exception because it's not going to be available to me. And the way the server is going to make me know what I can do is through these links. And the second benefit gets back to this scalability, evolvability thing. Because those URIs now become opaque, that server could change those URIs on every single request and send me someplace different. And my client is not affected at all because it doesn't know anything about URIs. It only knows about rels. It only knows about the business process. That for me has been the most powerful statement or realization about what REST brings to the table. And people are building these systems today. Yesterday in my talk, I said how Best Buy has built this cataloging system, and they've really taken advantage of hypermedia as the way to allow clients to discover what they can do. But where it gets interesting is clients in this world get built in a way that they ignore the things they don't know. They don't break. And a great example of this, if we think about this order processing system, imagine this is something like an online catalog. And they decide that they want to put a rewards program into effect where, every so often, certain number of purchases that I do or a certain percentage, I get some type of benefit. Now, I've got these old clients that don't know about that capability. What happens is suddenly when we upgrade the server, we offer up a new link. And that new link says, follow this. Basically, what the rel means is follow this if you want to create an award card or an award account so you can basically be accruing benefit. And then when you go to pay, there's actually an additional link, and that link says if you have an award card, you can use it. Now, when I'm saying you, I'm really talking about systems talking to each other. Hey, system, here's this thing we have. The first thing that's really interesting about it is even if I'm an old system, the server is still advertising to me that this thing is available. If I'm doing monitoring on my system and stuff, I can see that, hey, there's this additional data that's coming back. Maybe we want to look into that. In the SOAP world, I would never know that. I would just break, and then I would go and refresh. The other thing is the media types, in the SOAP world, all I know is signatures and parameters. I don't have semantic meaning. The WSDL document doesn't describe the business. This does. This associated document describes how our business process works. Is all this making sense? Any of it? Sound too pie in the sky? Okay. So why did I get into all of this? Because in the work we're doing in Web API, we want to enable people to go as far as they want to with HTTP, including doing hypermedia. Because we believe, and we're seeing customers that are saying, look, we want to leverage that scale and that evolvability that the web brings us. We want to be able to take our servers forward without breaking our clients. So the question is, how are we enabling that? Well, as I said yesterday, to play in this world, it's all about HTTP. HTTP is top dog in this world, and if you're not taking advantage of that, you're not going to be able to accrue those benefits. So for us, In order for us to give you an experience that allows you to do that, we've got to deliver a platform that lets you do whatever it is that you want to do. So we've talked a lot about this hypermedia thing. I thought maybe doing a demo would be worthy. So one of the things that we're doing in Web API to provide for this kind of capability, and to be clear, at this point, we're not providing a turnkey solution that's going to let you do hypermedia. We're providing a platform that has the right hooks in place to be able to do that. And over time, we will build on that, but we've designed this in such a way that people in the community will build on this now. You won't be blocked. We've been cognizant about making sure the right hooks are in play. So I'm going to show you a demo here. There's been this application that I've been working on, which I'm calling REST Cart. And the goal is to build a reference implementation, because unfortunately, there's not a lot of good ones out there, to show people how to build RESTful systems and how to do this hypermedia thing. And I'm planning to actually open it up as an open source project so other people will be able to contribute. I'm just trying to get it to a point. And you guys are going to be the first ones to see it. And I can tell you, I really built this for you. I started this on the plane, and I've probably put 30 hours in since I got here building this thing out because I want to show you guys what the possibilities are. And I promised a couple of people yesterday that I would show something, so I'm going to show something. So the idea of REST Cart is this. I'm a catalog system where you can browse my catalog, you can find items, you can put them in and put them in your shopping cart, and then you can take your shopping cart and carry it through and have your orders be fulfilled. Not all of that is working. But the key thing about this catalog system is it's going to evolve over time and the clients are not going to break. The clients are going to use hypermedia and they're going to get fed from the server what the next things are that they can do. At the same time, though, I might want to have a web browser just talk to me and just get back representations that don't have those links in them. And HTTP says you should be able to do this. I should be able to say, and I showed this in my demos yesterday. If I come at you with OData, I should be able to get OData. If I come at you with XML, I should be able to get XML. So we don't want these links to get in the way of the systems that don't want it. It's more of an opt-in thing. So I'm going to show you both. The other part to this system is it's an exploration for me into domain-driven design. If you guys have heard of that, pretty popular out here. Eric Evans' methodology of how to build business systems that are also very evolvable. So it's going to have both angles to it. And as I show it, then we'll get into what are the parts that are related to our web API. So if I show you the solution, there are 3 projects in here. There's tests, there's web, and there's model. Model is all kind of the domain-driven design stuff. So let's just run this. And it's not completely fleshed out, just to be upfront. So if I go here and I say product, so I get back in XML a list of products. And you notice there's this links thing down there. Actually, that shouldn't be there. That's a bug. I'll fix that. But this is the example of where my client doesn't know anything about hypermedia. It's a browser that just wants to pull down some XML or some JSON. As a matter of fact, I can still get that back in JSON as well. So if I go to Fiddler, copy that URI. Fiddler stopped working for me as well as it used to a couple of weeks ago. I have no idea why. So I can go here and I can say accept application/JSON. And now you can see I'm getting back JSON. No links, just JSON. So here's where the hypermedia thing starts to come in, but I'm just going to show you one other thing first. So we have product, we have cart. Oop. Oh yeah, because you have to put the, yeah. So here's a shopping cart that's already existing in the system. Now this is unsecure what I'm showing, because obviously you wouldn't want to let anybody be able to browse anybody's shopping cart. But there's ways of dealing with authentication and everything else. That will be here ultimately in the sample. It's not there yet. So here I can see there's one shopping cart. It has items in it, etc. So the real question is, how did those items get in that shopping cart? How did that shopping cart even get created? Traditionally, the way that would be done, as we were talking about, is the client would have all this knowledge and have to know, here's the different URIs, here's the different services I can access. But we're going to flip that. So when we go back to our product page, there's no information here that actually shows me what I can do. Not yet, at least. But if we bring in some hypermedia, we can actually change that. So what I'm going to do now is I'm going to go to Fiddler, and instead of getting JSON, I'm going to get a new media type called application/VND REST cart plus XML. So I'm now saying that what I want to get back is I don't want just a serializable representation. I actually want to start taking part in this application. And server, please guide me. Okay, so the first thing we see, if we zoom in, our content type. It's not just application/XML. The server obeyed. The server said, yes, you want that, I can give it to you. It doesn't have to. The power of HTTP is the client can actually send preferences, and that's what just happened here. If I had sent it a preference it didn't know, it can reject it and say, sorry, I don't have that. But in this case, fine. And I did know that first URI. You might say, well, how did you know how to get there? Yes, but the idea here is once I've hit that first URI, I should never have to build URIs again. They should all get built for me. So if we look down here, now when I browse the catalog, in addition to getting the product information, I have a link. Actually, that should be attributes. That's just a code thing. I'll change that. I have a link here that has two parts to it. It has a URL. And in this case, that URL says forms/cart/add-item/1. I don't have to do anything with it. I just have to use it. The server sent it to me. And it gave me a rel. And that rel says add item. Great. So if I have that media specification, or the RFC that the company has created, I can say, add item. Oh, add item means that's telling me I'm able to add something to the system. The next question is, what do I do with that link, though? Because HTTP has all these different methods. So there's different philosophies on this. One philosophy is you add additional annotations within your within the links themselves that say, like, this is what the method is, this is what the type is, etc. The downside to that is it pushes more burden on the client to have to know how to parse that, and browsers don't know what to do with it. The markup just gets ignored. The second approach is it's just in documentation. That's okay. I mean, it's workable. But it'd be nice if there was some way to not have to always go to the document to figure out how to work with things and to find out if that's changed. So we can take a lesson from the way that HTML works today. With HTML, if the server wants to get some information from me, it can send me a form. And that form has a bunch of input boxes that are, displayed in such a way they have a description that I, as a human being, can tell what that is, and I can then do a post or a get, depending on how that form was set up. The server might have set up that form such that when I enter those fields in, they're going to get posted, which the semantics of that is, hey, I'm sending something that's going to change the state of the server. Or it might be a get, and the get is more for like searching. There are plenty of people out there that are using get in ways that it shouldn't be used. But when the browser gives you that ability in an HTML form to use a get, it's not to offer you a convenient way to just throw it in the URI. It's because you're not actually modifying the state, and because the URI is the portion that's cacheable. The caching servers don't look at the body. So if I do a search, it's like that's not causing any change. That means those intermediaries could sit in the middle and say, if somebody else does that search, I can give it to them. I can give them the results because the results had a caching policy associated with them. So we can take a lesson from that and say, what if we create a new kind of form? Not an HTML form, a custom form. But the same concepts apply. The server gives me a bunch of information and tells me how I can go to the next step. That brings simplicity because now every time I see one of these links, I just do a get. I could even copy it into a browser if I wanted to, rather than having to have this complicated logic. So let's take that URI that we just got back, which the server formatted for us, and let's go and copy that up to our request builder here. Fix it so it doesn't break. Put a slash. Let's use the XML. Where's that view? Where is it? Text view, image view. What happened to the XML one? It went away. Let's try that again. Ah, there we go. Okay. So what we see that I got back, the reason I'm showing it to you in this view is because I think we have a bug we need to fix in our serializer it's not formatting it pretty. It's valid XML. It's just that when you look at the raw, it's not very easy to look at. I mean, yeah, you can try. It's basically pre-filled a form for me. And it's given me back a bunch of information. It said, this is the method you're going to use. You're going to use post. If it was a link that was related to a delete, that method would be set to delete. Maybe I did cancel. Maybe rel was cancel. So that means my client doesn't have to know, because it's just dumb. It just follows what, it just has to know that if I get a form back, these are the kind of things that will be in that form. But look at what else it gave me. It actually packed in, it gave me a URL. So it said, you're going to post to this URL. You're going to post this item to a sub-resource of the cart. And this is the cart number that you have. And this is where you're going to put your item. So this is equivalent to the browsing experience, only it's feeding the information electronically to allow non-browser clients to participate. And the last thing it did was give me the item. So all I gave it was an ID. Well, why is it interesting for me to have all that information pulled down? What's interesting about that is REST is all about maximizing your resources on your server by keeping state off of the server. So by pushing this state to my client now, the server doesn't have to do things like worry about what was the price that I guaranteed you when I gave it to you. It could give me a token, and it's given me a snapshot of the item at that point in time, and it could still guarantee me for a period that I'm going to get that price. But the idea here is there's no session state that's going on. Everything is being handled through these links. So the links are what maintain the state of the application. Does that make sense? So this is just simplified, but you could imagine I could get 3 links back, and I could keep going, right? So now I could go and I could take that and I could post it. So let's do that. So I have that pre-done here, I think. So let's imagine I browsed for Final Fantasy. So I'm going to go copy that into my request builder. Change it to a post. It's giving me that red because it's saying, sorry, you can't send that. And in this case, I'm just going to use application/XML, which is fine. And I'm not going to post it now to forms cart add item. I'm going to post it to cart/1. I think it was cart/1/item. Let me double check just to make sure. And then we'll see how this works. Cart. Okay. Actually, this is something different. This is actually sending a full shopping cart. I don't have the items part working yet. Anyway, I think you get the basic idea here, that the server is feeding information, the clients are adapting to that information. That allows me to change URIs and all kinds of things. The clients still continue to work. So the question is, how are we allowing you to do that kind of thing? And one of the things you noticed was when I did the XML representation of the item originally, where I didn't call for the special media type, the links weren't there. So the things that we have going on here are, we're doing a bunch of manipulation based on what the client is asking for. So if we look at this sample here, and going off of what we covered yesterday, hopefully you were in my talk yesterday, I'm mapping a bunch of resources to routes in ASP.NET. Those are going to be exposed, so you can see the URI over on the right. I'm exposing this as product, this is cart, this is forms, cart, add item. If I jump into the product, okay, so this is the product model, which has the links on it. This is a DTO, meaning this is not my entity that came back from my domain. But if we jump into the product resource, well, first thing we can see is I'm taking advantage of using an IOC so that I can inject the repository in, so in a unit test I don't have to have the real repository loaded up. But here I'm doing this get, and I've created this product list, which is a DTO. If I drill into it, it's got a list of products. And then the product has a collection of links. But we notice that those links, which again shouldn't show in the wrong times, they showed as empty before, they got populated under the right conditions. So how did that happen? So one option here is I could write that code right here. I could start populating the links, but then I have to write a lot of code that checks and says, what are the accept headers that the client sent in? Did they call for this? Did they call for that? Okay, they called for this. That's going to get to be ugly code, and it's really not the code that I want to put here. I want this to be very focused on the business code. So in Web API, one of the things we want to enable you to do is to separate out your HTTP concerns. If you saw the talk that I showed yesterday, I showed how you were bringing in these HTTP response message, request message in the service to let me get access to headers and things like that. And we do allow that. That's the simplest way to do it. But for those that want to build more maintainable code and rip that out, we are introducing a set of pipelines that allow you to just get in the middle and watch HTTP traffic as it's coming in or is going out and do whatever you want. And one of the things we're allowing you to do there is to plug in your own custom support for different media types. So when this list gets returned, it doesn't have any links on it, but yet we saw when we got to the browser and I had called for that special media type, I got the links. And the reason that worked is because here in my registration, so this is my IOC code, don't worry about that. I've gone and used the Fluent API to add a formatter called a REST cart formatter. So I'm teaching my server that in addition to XML, JSON, etc., you also understand this REST cart format. In that formatter, I'm specifying the media type, which is this application/VND REST card. And then I'm going to have these different few methods that I can implement. One of them is called onCanWriteType, because just because somebody asked for a particular media type, if the resource that they're on doesn't support it, I don't want them to get that back. So we give you, to make that easy, we give you this method here, this override onCanWriteType. And in onCanWriteType, I'm looking at the actual type that's coming back from the operation, in this case, which is a product list. And I'm saying only if it's product list do I want to support this custom media type. because otherwise it's going to blow up. It just doesn't know how to deal with it. And of course, I could expand that to add other things. And then what I'm doing is, as I'm taking the collection of products that got returned from the method, and I'm manipulating it. I'm applying my logic to add my links right there. So I didn't have to push that into the code. That got encapsulated in this media type formatter. That means if I have multiple places in my system that are utilizing this hypermedia format, the developers that work in those parts of the system don't have to be bogged down with putting all these links in. But furthermore, it means I can change the way the link strategy works without having to modify the code of the service. The service doesn't know about this. Does that make sense? And here you can see that I'm just going and adding add item. Of course, I could add other kinds of things. So that's plugging in formatters. The other thing I'm doing, and we want you to be able to have your cake and eat it too. So if you don't, as I showed yesterday, if you need to really access HTTP, you can get to it. Like here in my post, I'm setting the location. So if we run this, and hopefully the post works this time. Application XML. Okay. Oh, I see what happened. I posted it to cart/1. I'm supposed to just post it to cart. Oh. Just look at that. Why is that? This definitely was working in my room. Famous last words. Let me just try one other thing. Is that causing the problem? XML, product number, description. No, it all looks good. Oh, all right. Well. Yeah. Always fun when that happens. Okay, let's move on. So that's just covering this hypermedia thing and how you can enable hypermedia. So when people say, can you do hypermedia in WCF with our web API, the answer is yes. Today, there's still a bunch of things you do. We just don't get in your way, and we make it easy for you to do it once you've decided what you want to do. I expect over time there will be more out-of-the-box support that we'll add as an add-on for making these kinds of things better. But the industry is still young at doing this kind of stuff, so we're working with folks and watching how this evolves. But I really advise you looking more into this, because I think it really can offer some tremendous benefits. Now, you don't need it for everything. The places where this is going to get interesting is where, when you start to service lots of different clients, iPhone, Android, this, that, all these different clients, and you want to be able to move forward without having to rev all those clients. And this gives you that flexibility of doing that. All right. So that's just one example. Let's see another one. We'll go back to the contact manager. So the contact manager supports all these different formats. And we saw that working through accept headers. We saw that I could take this URI, and I could go, say, into Fiddler again, and I could change this to a get, and go post this URI here, and I could say, give me, why did it change that? Get. Okay. I could say, give me application / oh, I see what's happening. The host was throwing it off. Okay. That's why that other thing wasn't working. I could say, give me atoms plus XML, and I get back, ooh. Okay, this is not good. Oh, I didn't specify the URI correctly. Yes. I get back OData. but I can't, not all my clients are going to be able to send those headers. For example, if I'm going to use PowerPivot, and for those of you that are not familiar with PowerPivot, PowerPivot allows you to take OData, and it can allow you to work with it and query and analyze, and it's part of Excel. It's an add-on for Excel. But PowerPivot only knows how to talk to URIs. It doesn't know about accept headers. And my machine was just reformatted, so I don't have it. So the question is, if I'm on a client that is not able to send those headers, or we can go back to the Gmail example. When I did the Gmail example yesterday, I pulled in the contacts. It said, give me a vCard. I had to give it a URL. So if I go here and say contacts/OData, that also works. But on the server, our standard implementation, because this is really the way HTTP was designed, is that we look for those accept headers. So how does this actually work here? How is it able to understand that URI that I put in the browser, although I haven't specified the accept headers? For these kinds of things, we want you to be able to get in the middle and do whatever you want. So what you can do is you can create a custom component. We call them message handlers. And what that message handler can do is it can receive a mapping that says that for this extension in the URI, this is the media type. And I can give it a list. So if you look here in my global.asax, I've got this mapping where I'm passing XML matches to application XML. JSON matches to application/JSON. I'm setting it up to say that if a URI ends with one of these extensions, this is the media type that I want you to use. If I look in my channel, then what's happening is and all you have to do to write a channel is implement one method, and it takes advantage of the new task parallel library that we have in .NET 4, so that you can do things in an async manner. It's not going to be blocking. And what I'm doing here is I'm listening when that request comes in. So if we run it again, I'm getting right in the middle, and I'm modifying the request before it ever gets to the upstream parts of our framework that do the content negotiation. So I'm able to trick it, so to speak, and say, it looks like the client sent those headers even though they didn't. So if I go here and put contacts again, /OData, you'll see it. So what this is going to do is it's going to look at the last segment of the URI, which it sees as OData, and it's going to try to match it against the mapping. And if it found it, now it's going to go and it's literally going to rewrite the URI right there. It's going to say, currently, your URI has within it OData top 1. After the rewrite, it doesn't have OData in there anymore. To remove that out of the URI. And the advantage of that is it means that the implementer of the service doesn't have to worry about dealing with these extensions. They don't have to have parameters on their methods and things to deal with parsing that in their templates, because otherwise you would. If I didn't have this logic here, what would happen is every developer who was implementing the service, when they put their URI template, and the URI template, just to show you what I mean, like here, you can see when I'm doing this get, my URI template is empty. If I didn't strip that off, the developer would be forced to reserve a variable within their URI template in case I passed that information. Otherwise, it would just break. So by being able to get down at this low level, I could just do whatever I want. And now I'm going to the request, and I'm clearing the accept headers that came in, and I'm replacing them with the media type that I matched on. So the point I'm trying to show here, and if you get to the theme of the talk when I talked about unlocking the secrets of REST, really being able to build good RESTful systems means you have to be able to have control of HTTP. And we're giving you the ability to do that across our stack. And you can do it very close to where you write your logic, or you can move it out to be more of like a policy where everybody doesn't have to worry about it. That make sense? Let me show you one more example. So this was an example of where I was actually doing some rewriting, but I can do other stuff. I can do logging. So I have a logging channel, and that logging channel right now is just writing out to my debug window. But the advantage of doing it at this level is, even if there was no service defined, like if I go HTTP, here, let me run it again. Let's say that the URI doesn't match for whatever reason. Somebody just called to a resource that doesn't exist. I'll still get the chance to log on it. So if I go like contacts, I don't know, whatever. Oh, wait. What should have hit? So I just entered some random URI in, and you can see that I came through my logging channel, and I was able to log the request. So I could work with logging infrastructure or the event log and capture whatever metrics that I want to capture and do it in a way that's out of the way of the developers that are writing all the business logic. I can also use this for things like API keys. So if you work with any of the web APIs that are out there, like Facebook or WordPress or NuGet, it's very common that you get this key. And that key, you're told, is like your password. Don't give it to anybody. But when anybody's going to make a request to your system, you're going to require that that key be there. Well, today you can do that kind of thing, but it ends up going all the way upstream, and developers have to worry about it. We want to make it really easy to say, hey, if you want to address those kinds of things, you can do it without having to go through a lot of pain. So if I come to, I have this API key sample, and it's using the same extensibility point. It's using the channels or the message handlers. And so if I run this, it says, welcome to API key verification sample. And it's giving me an API key there, and it's saying, if you do get all contacts, I can get the contacts back. But if I whack it partially, access denied. And the reason I was able to do this is because I have a message handler that sits right in the middle and looks at the request when it comes in and says, I'm going to look to see if that API key is present. And if it's not present, I'm just going to immediately return a response to tell the user that they're unauthorized. And we're going to use this for other things in the future. We're going to use we're going to use this extensibility point for things like OAuth, which is something that we're investing in to make it easier for folks that that want to secure their systems. So if we look at this one, we have this API key verification channel. And this is looking for some specific headers and verifying whether or not that I've passed in the right information. If I haven't passed the right information, what you can see here is it's generating a response that says it's an unauthorized request. So I would argue that it was if you look at this, that's not a lot of code. It's pretty simple. It's pretty intuitive. When you write a channel, the only part of this that's WCF requiring you is this one method here, send async. And send async has those same request and response messages that you've seen. Now, we've got another extensibility point which allows you to do some other really interesting things, which is we've shown how with formatters we can take parts of the content of the message and we can convert that into objects arbitrarily. You can plug in as many as you want and support whatever custom formats you want. We're also allowing you to do other kinds of things. Let's say you want to do validation. But at this level, you're really dealing with just bytes. The body hasn't been transformed yet into an object. So it would be a bunch of code for you to have to deal with that here, especially if you wanted to deal with lots of different formats. So what you really want to do is say, okay, WCF, Web API, convert this into an object, then let me step in the middle and get that object and do something with it. Validate it, check it, whatever. So for that, we have another extensibility point, which we call operation handlers. And the way an operation, and what's different about operation handlers and message handlers, if I jump to this diagram, is the message handlers, which is what you just saw for logging and security and for the URI stuff, is for really low-level things that only relate to HTTP. And what I mean by that is there's no correlation to the operation that's actually going to get invoked or the objects that will be used there. So all I know about is a message at this level. The handlers, however, have much more context. They actually know about what object the body's been turned into, and in addition to the body, they can even do things like access the URI and turn a portion of the URI into an object. So what I mean by that is, if you came at me with contact/1, I could write a handler that takes that 1 and turns that into an actual contact object so that the operation, instead of getting a 1, actually gets a contact. So anything that you want to do that relates to taking the information coming in from HTTP and turning it into objects, you can do at that level. I have a pretty good demo on this, which I will build if it's not here. My machine was recently completely reformatted. Just double check, see if it's there. Okay. Let's do this. Let's go back to our contact manager sample. Let's imagine a situation where I'm going to have a map. And that map is going to allow people to specify in the URI coordinates. Location/100, 100 would be latitude and longitude. But the code that's actually going to handle that doesn't want to have to take that latitude and longitude everywhere, because it's going to be all over the place, because it's a mapping system, and have to manipulate it. It really wants to just get a location object. And I might want to offer flexibility, because I could, that says, hey, you could give me latitude, longitude, or you could just enter city, state, zip in the URI, or province, country, whatever. And still, the code on the handling side just gets this location object. So let's see how we would build that, and we'll see how our operation handlers come in for helping us to do that. So I'm just going to create another resource. We'll work out a one class file for now. And I'm going to call it, I'll call it map. Actually, I'll call it map resource. So I'm going to annotate that as having a service contract. And then what I'm going to do is have a get operation, and that get operation is going to allow somebody to come in with a URI and pass me a location that they want to get some information about. And for now, I'll just return a string, and I'll say get. And what I want to do here is, normally what I would have is a URI, I'd have this URI template. And in that URI template, I would have something like latitude, comma, sorry. Oh, sorry, that's all wrong. It's web get URI template equals, quote, latitude, comma, longitude. So normally what I would do is I would now put latitude, longitude, but that's not what I want. What I want to get is a location. So I'm going to create a class here called location. And it's going to have on it a latitude and a longitude. Actually, we'll change it to a double. Okay. Now, I'm now going to change this to take a location. And then the return value, as a matter of fact, I'll just return the location. That's fine, because it'll just serialize it into XML. So instead of, this is probably not what I would do, but I'll just to illustrate, that's what I'll do. So I'm just going to return it. So the challenge here is, how do I get from that URI template that has latitude and longitude to an object? And this is where our operation handlers come in. So I'm going to write one. And if you look at the naming, we have message handlers and operation handlers. So message handlers relate to the message. Operation handlers relate to the operation. That's how you should think about it. And this is going to inherit from HTTP operation handler. Now what we've done here to give a nice experience, we've got a bunch of conventions and we have a whole bunch of generic classes. And those generic classes, the first parameter, the last parameter is going to be the output parameter. So you can have as many parameters as you like, up to like 15. It's like func, the way delegates work. So what I'm going to do here is I'm going to say that I'm going to get two parameters, long and long, which is actually going to be the input of the latitude and the, sorry, double double. And I'm going to expect that I'm going to return a location. I left out an L. Yes. So once I do this, I'm going to get a single method that I have to implement called onHandle. And onHandle is going to need, do we have two methods? In a minute. No. What's it messing up about? What doesn't it like? Base classes. It doesn't contain a, yeah, that's fine. Doesn't have a parameter list constructor. So I need to tell it what's going to be what the output parameter is going to be. And we use a convention here. So if you go back to my resource, you can see that my resource is getting a thing called location. So the convention is whatever string you name there, that's going to match up to the parameter name. So when I call my base here, I'm going to specify location. Make sense? Location is matching against that location input parameter. I'm saying this is the name of the thing that I'm returning. And if you look on the generic definition up here, that type is location. Once I've done that, I can now new up a location object. I can say, now, there's another convention here. It doesn't know what input 1 is or what input 2 is. So the convention here is I rename the parameters to match what I'm expecting to get from the URI template. In the URI template, I defined latitude and longitude up here. That's what I'm going to have to put down here. So I'm just going to name these variables to match. Once I do that, then I should be able to set my latitude and my longitude. And return my location. So I'm almost done. The next thing I need to do is register this handler. Because I've written the handler, but it's not going to just wire itself up. I need to wire it. So the way I do that is I go back to my global.asax. And actually, I need to do one other thing because I'm using MEF here as for resolving my resources. So I need to, where the heck was that? Oh, map, here it is. So I need to put an export on this map resource, or MEF won't find it. Okay. So now if I go to my global.asax, I have this ability to add in operation handlers. So on my Fluent API, you'll see that I have this add. Oh, put that dot there. I have add request handlers and add response handlers. In this case, I'm going to do it on the request side. I'm saying that when the request comes in, I want to basically pull this location thing out. So I'm going to now, I get an action of handlers, and I can go and add to them. So I'm going to go add. And when I add, I'm going to add my new handler, which is my location. Where is that thing called? Map. Location operation handler. It's ugly. Let's just shorten it. Location handler. There we go. So I'm going to add that. And then what I get to do is I have a func. If I want to say that this doesn't apply to everything, it only applies to certain types of operations, I can actually put a condition there that will say only apply this in the case of if the resource is map. So I'm going to do that. So I have here on the second one, I get a couple of things. I get an endpoint, an operation description, and this Boolean here. And with the endpoint, I can actually go to the contract type, which is here, and I can check to see if it is my map resource. So what I'm doing there is I'm saying I want you to add this operation handler, but I only want you to do it under certain circumstances. Why doesn't it like that? Parameter E cannot be declared in scope because you give a different meaning to E. Okay. Let's call it EN. Well, it still doesn't like it. Why not? EN contract type. All right, let's drop that. Let me see. Func endpoint description. Oh, there's no B. That's a Boolean because it's a, there we go. Okay, good. Does that compile? Semicolon here. Is it not base location? Ah, yes. Thank you very much. Good, succeeded. So now I need to map my route. I'll say route table dot routes dot map service route map resource, and we'll just put it as map. Pass in our configuration class so that it gets the operation handlers that we added in. We're almost done. So what I want to do is put a breakpoint on the handler to show you the handler actually in effect. So that's here. Let's put a breakpoint here. So if I go map slash 100, 100, there we go. So it hit my handler. And now you can see that I have right here my latitude and my longitude. So I was able to take my URI, turn that into an object. But you can use these operation handlers for lots of things. I mean, again, this is just one of the scenarios. One of the things we're going to do is probably ship one that works with data annotations. So if I annotate my models with data annotations, then we can do validation. And we can automatically look at the entity and say, hey, if this field is required or something like that, then we automatically just reject it and send it back to the client. And that would just be something that you plug in. So the important thing I want you to think about from what I showed you here is that this is for you. It's not just for us. We're using the same extensibility points that you can use. We're not doing some secret thing that only Microsoft can take advantage of. And this is part of allowing you to unlock, as I said, those secrets of REST, which are all buried within those HTTP requests and responses. So all of this is available today. This sample's not out there, but I'll put it out there. But the contact manager and all that other stuff is all available on wcf.codeplex.com. This project is in development. It's continually releasing. You can go grab it, check it out, give us feedback. We're still evolving, and we're interested in your feedback. Thank you very much. I'll hang around if people have questions. Thanks.